All right, here's our last video of the semester, and we're just going to practice some of the graphing of these rational equations. Let's take one. What if I started with f of x equals 4x plus 12 over, let's say, x plus 2. Okay, well, we want to use our handy-dandy chart, that is for sure. And right off the bat, we can get the vertical asymptote because the vertical asymptote is what makes the denominator 0. And that would be -2, wouldn't it? So that's the vertical asymptote is going to be fx equals -2. All right, what about the horizontal asymptote? Well, my degree is linear on both the top and the bottom, so the n equals the d, which means that I use the y equal to the lead coefficient of the numerator, that would be the 4, divided by the lead coefficient of the denominator, which would be 1. So there's your lead, 4 and 1, so that's y equals 4. All right, so that's good. Let's draw that. The horizontal asymptote is y equals 4. I think these are kind of fun. I know you agree with me. And x equals -2. That's going to be over here. Okay, and let's find some intercepts, and that's going to help us know where this graph goes. The x-intercept is a 0, and that's what makes the numerator 0. Well, that would be 4x plus 12 equals 0. X would be a -3, wouldn't it? So the x-intercept is -3. All right, let's draw that. That would be right here. That's 2, -3 right there. All right, and what about the y-intercept? Well, the y-intercept occurs where x is 0. Okay, when x is 0, this becomes 12 over 2, which is 6. Is that right? Did I do that right? Yes. Y, 6. So it's 4, 5, 6. Okay. Well, there we go. That's going to be up there in that corner, and this is going to be down here. And there's your graph. Okay? Let's go on to another one. What if I had to write an equation with a 0 of -5? So this is number 2. I'm going to do a 0 of -5. And I want to get a vertical asymptote of 2. Okay, well, if a 0 is -5, that means that the numerator has to be made 0 with a -5. So that's going to be f of x equals x plus 5, right? Let's check it out. Because if the 0 is -5, if I put a -5 in there, that would make the numerator 0, and that would give me a 0 there. Yep, if the vertical asymptote is 2, then I want x minus 2 in the denominator. That'll give me a vertical asymptote of 2. Okay, that's all there is to that one. Let's do another problem. Let's say, okay, this is a little bit different than what we've done before. Let's do f of x equals 1 over x minus 2 plus 3. Oh, so I've definitely done some transformations. I've transformed this by translating it 2 units to the right, and this would be 3 units up, wouldn't it? Now recognize that before we were just using the 1 over the x minus 2, and you'd have a horizontal asymptote where your denominator is larger than the numerator, so you had y equals 0 as your horizontal asymptote. But now you're adding 3 to everything. That's going to move your horizontal asymptote up 3 units. So the horizontal asymptote is y equals 3 instead of 0 that it would have been without that 3. And again, following when we're finding that horizontal asymptote, you look at whether the numerator or denominator degree is larger. And in this case, the denominator degree is larger, which means that you have a y equals 0. But this 3 moves it up 3 units. What about a vertical asymptote? Yeah, should have one of those too, shouldn't we? Because 2 would make the denominator 0. So x equals 2 is my vertical asymptote there. And again, I know I've shifted this thing 2 to the right and up 3. What about some intercepts? Well, the y-intercept occurs when x is 0, so that's -1/2. This becomes -1/2 plus 3, so the y-intercept is going to be 2.5, right? And what about the x-intercept? Well, there is no x-intercept, is there? Oh, but there wouldn't be if it were just 1 over x minus 2. But remember, I've shifted this thing up 3 and 2 to the right. So this is going to have an intercept. Let's find out what that would be. That's when y is 0. So that's going to be 0 equals 1 over x minus 2 plus 3. That's going to be -3 equals 1 over x minus 2. I'm going to multiply both sides by that x minus 2. That's going to give me -3x plus 6 equals 1. So -3x equals a -5, and x equals 5 over 3. Okay, there is an x-intercept. Let's draw this out. All right, I know the horizontal asymptote is y equals 3. Of course, you can check these in your calculator, but it's so much better if you can do them just using your algebraic knowledge and without the calculator. Then you can check to see if it's right. Vertical asymptote at x equals 2. Okay, we've got an x-intercept at 5/3. That's going to be right in here, isn't it? And we've got the y-intercept at 2.5. That's going to be right here. So these are both points here are going to be this lower part of the graph. And that means it's going to have the opposite in the opposite corner, and there's your graph there. Pretty cool. Go to a couple more. Okay, let's do number 4. We'll do f of x equals x squared plus 7x plus 10 over x plus 4. Okay, well, to find the zeros, first of all, those are the values that make the numerator 0. Oh, can I factor that? Well, yeah. See, this is actually x plus 5, x plus 2 over x plus 4, isn't it? Okay, well, that means I've got x-intercepts at -5 and -2. So x-intercepts -5, -2. What about the y-intercept? That's when x is 0. Well, if x is 0, that's going to mean this is just 10 over 4. So that's 2.5. Good? All right. What about the asymptotes? Well, a vertical asymptote is at x equals -4. That'll make the denominator 0. What about the horizontal asymptote? Well, the degree on top is a second degree because that's a quadratic, and it's linear on the bottom. So the degree of the numerator is larger than the degree of the denominator. And what does that mean? There is no horizontal asymptote. All right, let's draw that. This can be a little bit different kind of a graph. I've got intercepts at -5 and -2. So that's there and there. And I've got a y-intercept at 2.5. That's going to be there. And I've got a vertical asymptote at x equals -4. Now, this is an interesting graph. This graph actually looks like this. Ah, that looks different than some of the others that we've done so far. Very interesting. Let's get another interesting graph. Problem number 5, we're going to sketch f of x equals x plus 3 over, let's do x squared plus, let's do x squared minus x minus 20. Well, that factors to what? That's x minus 5, x plus 4. Okay. So, x-intercept, that would make the numerator 0. So the x-intercept is -3. What about the y-intercept? That would be where x is 0, so that would be 3 over -20. What about the vertical asymptote? Yeah, I've got 2 vertical asymptotes. I've got -4 and +5. So x equals -4 and x equals 5. This is going to be interesting. This will be a totally different kind of graph. And then finally, the horizontal asymptote. What's that going to be? Well, let's check. The numerator is a linear. The denominator is quadratic. So the d is larger than the n. When d is larger than the n, y equals 0 is your horizontal asymptote. Now remember with asymptotes, this is going to be a little bit different. It's at the extremes that you cannot cross the asymptote, but you can cross the asymptote, and we will in this case. So we've got vertical asymptote at -4, and at 5. Okay, and I am going to look for some help on the calculator here. I'm going to go horizontal asymptote, y equals 0. So there's an asymptote running right there. And remember, at the far extremes, right and left, you cannot cross y equals 0. Okay, the x-intercept is at -3. And the y-intercept is -3 over 20. That's going to be right in here. And this is a really strange graph. This is going to run like this. And like this. And like this. Wow. And quite frankly, I got some help from the calculator to make sure that that's the way that ran. This thing is really a strange graph. Okay, let's go to our last one. This is another thing that's a little bit different. F of x equals x squared plus 7x plus 12 over x plus 3. Guys, stop the tape now and first of all, guess what that is going to look like, and then put it into your calculator or computer and see what in fact it looks like. Then come back to the tape. Okay, it should have been a little bit of a surprise. This ends up being a straight line. And you say, how could that be? That's a quadratic, it's a rational function. How could this end up being straight? And that's because if you factor this, this is actually f of x equals x plus 4 times x plus 3 over x plus 3. And what happens here? Bingo. That cancels out to be a 1, leaving you with the graph of x plus 4. Now, that's not all. So, first of all, to take a look at that, so I've got 1, 2, 3, 4, and that's going to come up just like this, isn't it? There's only one little thing that's kind of interesting here. At -3, look in your table. There is what we know is called a hole. So when you have in your table, when x is -3, this is going to say air or undefined, because at -3, the original problem has no definition. It's undefined. It's division by 0. Now, that hole is what they call that, hole at -3. And that is a restriction on the domain. See, if I had the domain here, it would be all real numbers except it cannot be -3. Okay? So it is a straight line, but it has a hole, and it's a restriction on the domain, and it's that x cannot be -3. Otherwise, it's all real numbers. Okay. Guys, have fun with this. That's the end.